Hi, I'm Doug Bentley, Head of Product Development for Klarius Group. I'm here today at ADS with Frank Massey to talk about Quinton Hazel's range of products for timing belt and water pump changes.
Thanks, Doug. I think I'd like to begin with the technical approach for this presentation. Perhaps discuss some of the choices, some of the options. In other words, what set of events actually brings us to the point where we're considering a belt change? I think, first of all, there are, in my view, two possibilities. It's a service requirement or consideration and or a repair consideration. So let's perhaps start with the service consideration. I think for the benefit of presentation, with Doug's assistance, we'll assume that Doug is the customer. What I'd like to do is really discuss, you've asked me to price a belt change. From a technical point of view, potentially quite a simple job. Cost is going to be the issue that you're going to focus on. Now, what I'd like to do is try and persuade you why the cheapest option is not the best choice.
Okay.
Now, there's a lot of issues dealing with belt replacement, and this particular vehicle obviously has been exposed. We'll look at some of these practical considerations. If we perhaps want to change just the belt as a single item, the price and cost of that is quite affordable. However, there's a lot of other components that are relevant to a belt change. We're looking at tensioning components, we're looking at guide, bearings and pulleys, we're looking at ancillary or serpentine belts with automatic tensioners, we're looking at water pumps. All of these components age and may be an issue. This particular engine is pretty much a genuine example of one that's been removed from the vehicle, and there's evidence of oil leaks. Well, surely we should be considering whether we change the seals. It's an opportunity, in my view, to get the job right, to give you value for money and longevity of the repair itself. So that's the advice I give you. Are there any issues there which you disagree, perhaps?
No, definitely, and I think it's interesting to talk about this. So normally the customer would have come into the garage, maybe at a service interval, to look at replacing the belt. But we've also developed a kit of components to do at the same time, because it makes sense really for peace of mind to replace all of those vital components to avoid having to do them later at failure.
Okay, shall we take a look at some of those?
Yeah, let's bring them over. So initially we've got the serpentine belt.
This is the first item that effectively, once you've removed the covers, you're probably likely to arrive at. Serpentine belts have quite a responsibility these days. This is, in relatively speaking terms, quite a simple arrangement. We have a power steering pump, we have a generator, we have the engine pulley, we have air conditioning. So quite a simple arrangement. But the actual performance of this belt is very important. It's a multi-groove serpentine belt. We want to look at cracks, abrasions, ingress of oil, any physical damage to the belt. But the point is, even if the belt does look serviceable, it's probably already done at several thousand miles. The question is it going to cover the next interval of its expectancy, not what it's actually like now? Servicing is about preventive maintenance, not about putting back a component which you think is serviceable. So that's your first consideration. And don't forget, of course, the tensioner. We'll be looking at that in some detail later.
So here's the timing belt.
The most critical part or consideration is replacement of the belt. When should we make that choice or give advice about change of belt? Well, first of all, if you're not sure, there's a lot of information available from various systems. Take a point of actually looking at this information, because anything that's indicated in red is a critical consideration. Take a look at what's being written about perhaps serviceability. Is this engine a non-interference engine? In other words, if that belt were to fail, the engine will freewheel without any serious internal collision of components. If it's an interference engine and that belt for any reason has failed or has skipped a tooth, then there's a high probability that the camshaft components, the valves, will come in contact with the pistons, at least breaking a rocker, bending a valve, and at worst, very seriously damaging the piston and the engine itself. Take a look at what's involved with the repair. Take a look at the requirement procedurally and where any special tools are required. And of course, all important, take a look at the schematics. Don't make the fatal mistake of dismantling an engine and assuming the belt is right when you've dismantled it. On many occasions we've stripped an engine. First thing we do is pin it with the old belt to ensure the original timing position is accurate. And we'll come back to that later, but don't make the mistake of leaving it in situ and assuming it was right in the first place. Let's take a look at the actual kit that is designed and developed for this particular engine type.
Okay, so here we have a kit available for this vehicle. We actually recognised at QH that most garages, when they want to do this job, rather than just buy the timing belt on its own, also we can replace the associated components at the same time. It's much easier just to be able to order one part number to do that job. So very simply, we have the kit available, Frank.
Thank you. Critical components in this kit, obviously the belt, but let's focus on the other components. This is a guide roller, and the purpose of this is to enable a smooth running of the belt, to keep the position of the belt intact and to keep the relevant tension of the belt correct. The actual tension itself, this is a fixed tensioner. By fixed, I mean that there's no automatic self-adjustment. So basically, once you've managed to fit the component and actually adjusted it, it's an adjustment for life. Doesn't mean to say it might not need revisiting perhaps to check the tension. It shouldn't be necessary. It's set right in the first place, and the design criteria is that it will last. And it's a simple square-driven device. It's an eccentric device basically. This also has a bearing in it, and of course the belt runs smoothly on that bearing surface. So when you're examining these components, take a look at the track. Is there any abrasion, any damage, any cracking? These quite often have small cracks in them, and all important, listen and feel the bearing. Later on when we strip part of this engine, we'll actually be listening to the bearing. And if it sounds hollow or there's any unevenness in the bearing, then clearly that must be replaced.
And is it good practice, Frank, to replace all of those components at the same time? I mean, typically if the belt's nearly ready for a change, are the other components ready as well?
Absolutely. This is an opportunity to put right what is wrong in one easy movement. I mentioned before, any signs of oil leakage. Now is the classic opportunity to save the customer a little bit more money, but now is the time to do it. If you get oil on the belt, of course, in future, that's going to degrade the material in the belt and potentially lead to premature failure.
And of course, if you're going to replace the belt, the pulley might be nearly ready, but if you leave it till later, you're almost doing the job twice, aren't you?
You are. And you mentioned the water pump itself. The water pump is a stress component. Quite often, when you fit a new belt, the actual belt is more rugged. And it's quite often been the case that a perfectly serviceable pump has suffered prematurely following the belt change because of the extra tension that's put on with the belt. And of course, please ensure that your tensioning procedure is correct. Don't give it an extra turn or tension thinking one more is going to help. It doesn't. Correctly tensioned belt will ensure the life of the water pump and all the other bearings then reach their design criteria. But also, consider replacing the water pump. It's very important.
Let's take a look at one. So this is the pump for the engine that we supply. There we go.
Now, as an end user, I mean, I'm used to handling these pumps. Perhaps there's a lot about these components I am aware of and a lot I'm not aware of. Can you perhaps, for my benefit, explain some of the benefits of choice in components?
Yeah, just in summary, you've obviously got the casting, the body that attaches to the engine. We've got the gasket also supplied, and we've got the pulley on the front and the impeller on the back. So that's driven by the timing belt, and the impeller on the back is obviously helping the water flow around the engine. And of course, testing is really key to us. So not only do we supply aftermarket components, we also supply original equipment. Of all of our pumps, the bearings are tested for 2,000 hours. That's about 120,000 miles actual use. So they're really put through the paces before we release these to market.
So I can provide this with confidence to the customer that it's an equal OE specification.
Yeah, exactly.
Component. And also, I have noticed, I mean, the quality of the gasket as well is a high quality.
Yeah, we use an OE specification gasket, so if the original is metal, we tend to go with metal as well.
Yeah, and from a technical point of view, when you fit these pumps, ensure that your gasket faces are clear, of course. Quite often a bit of corrosion. Perhaps there's been some leakage. There are signs actually on here. If you can catch this on camera, this pump has actually weeped. You'll notice that at the base of the water pump, there is a drain hole, and that is often the location where any passage of fluid past the seal will actually come out, and evidence of that is on this engine. So, classic example, probably a serviceable engine so far as the previous owner of this vehicle was concerned, but clearly that water pump is at point of failure. It is actually failing now. What I'd like to do now, so we've discussed, okay, this is a fairly simple arrangement. What's he able to supply perhaps with some of the more complex belts?
Yeah, this actually, looking at the timing belt kits, it's a relatively simple kit with only 3 vital components. A much more complex vehicle here, it's the Opel Vectra. It's got everything in it you need to do the job, Frank. Do you want to talk through those components?
Okay, first observation here, clearly that there's been a conscious decision that new bolts are required. Equally important, many of these bolts now are tightened by torque. They're a stretch bolt or once only used bolt. So once again, refer to literature. You can either gain the literature through printed format or electronically. Have a look through the literature. Where there are bolts and fasteners that are used once item only, please take very care and please replace those components. Very important. When you place your order for your components, make sure you order the right physical bolts for the job and take that into consideration when you price the job up as well. Moving on to the actual kit, this has 2 arrangements. Now, straight away, this is for a V configuration engine. There are, in effect, 2 eccentric devices here. That is the tension. This is an automatic tension. In other words, there is a component or device here which, when preloaded, that indicator will line up with that one, confirming the correct tension. So the tension decision is made for you in the installation process, that when you pre-tension the belt, you will align those 2 marks and then lock the device. This is a eccentric variable adjuster, and that's to take up the tension on this particular camshaft. So as I said, this is, as Doug has rightly said, a more complex type of arrangement. You'll notice these have deep guides built into them where most of these pulleys run free. These have guides on the belt. Otherwise, the actual technology in the belt, you'll also notice some of these belts can be directional, and also where there are indicators like this, these are important timing considerations. They will have a reference point on the physical component during the assembly process. So it's important that you have a quality belt with the correct markings, with the technical information for assembly, all the correct fasteners. It's all part of what we call a preparation process before we actually start the actual repair process.
In terms of selection, Frank, it's really easy. Just go onto our website, put in your vehicle registration or the VIN number, and that identifies the kit straight away.
I think what we can do now, here we have the actual engine as lifted out of the chassis. Let's go through the dismantling process, having a look at some of the examination. There's been a little bit of preparation. Obviously, we've got the tools ready. We've also got the various locking pins, which I want to refer to quite deliberately and carefully in a moment. But I did mention earlier 2 possible considerations. We've been discussing the service consideration. When should we replace the belt? The answer is at the correct mileage, or at a point when an external factor becomes a consideration. Now, what I mean by that is belts do not fail in operation. They only fail for one of 2 reasons: that their life has been exhausted, in other words, you've surpassed their service design life, and or there has been external influences, damage, often ingress of oil, water, physical damage. Incorrect installation is probably one of the biggest, where the fitting, where levers have been used incorrectly, or they've been over-tensioned or things like that. So belts don't fail in their own right. So when should we consider replacing the belt? Well, at the correct time is the answer, unless previously indicated, there are external factors. Being guided by the data, and it's quite complex actually, because you look at all the variants which use this engine, some of them have different intervals. Peugeot 307, which is the vehicle of choice, 12,000 mile service intervals, replacement every 96,000 or 10 years. Another consideration, 72,000 or 10 years, 160,000 or 10 years. So there's quite a consideration here. What about time and cost? Well, here we have removal installation. On this vehicle, we're looking at 3 hours, 3.3 hours. I'm a little cautious of that. As a customer, what I'm going to say to you is book time is 3.3 or thereabouts. However, there's additional work involved with this engine. For a start, there's going to be some cleaning required. I'm going to change the water pumps. There's going to be some preparation of the gasket surface, so there will be an additional charge. So rather than do the job to a price which puts me under pressure to cut corners, which I'm not going to do, what I'm going to say to you is, let's do the job right first time.
And that's right, Frank, because if you're going to replace just the belt, but all the labour work in the job is the 3 or 4 hours.
Sure.
For a little bit extra labour and a little bit extra cost on those components, it saves doing it again later, doesn't it?
Yes, it does. Yeah, it adds value to the car. If the customer is not going to be the owner of the car in the next belt replacement, the second replacement, at least then there's value in the vehicle because it's been done and documented correctly.
Okay.
The second consideration I mentioned some time ago was a repair consideration. Now, we quite recently, and throughout our history, have been involved with many repairs which have originated electronically. By electronically, I mean where there have been DTCs, diagnostic trouble codes, stored in the computer for things like coherence or camshaft sensor faults or crankshaft sensor faults. Just a little quick thought here, because it's quite important. Don't always assume that a DTC will be present when the timing is wrong. I'll cover that shortly. Don't always assume when there's a DTC that indicates the camshaft is wrong, when in fact it could be the crankshaft, or vice versa. So basically, I don't trust those codes. Equally, if it's a coherence problem, what the fault code coherence means is that the relationship or perceived relationship between the cam and the crank is not recognised. Then that could be quite literally a problem with the quality of the signal or the profile of the signal or the relationship between the two components. Another consideration. Quite a lot of engines now are keyless, and by keyless I mean there is no locking device or Woodruff key which holds the sprocket in a stated position. Therefore, it is possible that the physical gear is in the right position, therefore the electronic timing's okay, but the mechanical components, albeit the camshaft, are incorrect. And the main reason for this is because the engine hasn't been locked and pinned properly. A great number of technicians tend to take shortcuts and assume that because they've taken it apart, it must be right. Don't make that assumption. Lock the engine thoroughly, properly, with the correct tools, in accordance with the data, before you dismantle it. That gives you a guarantee that it was in the correct position initially. It could well be this engine suffering a performance issue, a fueling issue, or whatever, simply because there is a mechanical error in the assembly. So that's the second consideration, a diagnostic fault. And it's one of the most common problems we come across is timing. This particular vehicle has common rail injection. Therefore, as a high pressure pump is driven in our case by a belt, not directly mechanically driven off the camshaft, but driven by a belt. Strictly speaking, this pump is not timed. In other words, there is no locking device for the pump, but there is a theoretical position for it, which is an advantage. So because there's no locking device, what I am going to do is I'm going to mark one of the teeth. I'll choose this one. I'm going to mark the casing. Now you may say I've just made the comment about accurately locking the device up. Yes, I have. I am not going to remove that nut. Therefore, that sprocket can only be 1/2 out in either direction, and that is easily compensated for in that mark. So I'm confident I'm going to get that pulley back in that position. You may want to centre pop it perhaps with a centre pop and on the back cover. Whatever choice you make sure it's durable and that you can see it easily work for reassembly. The camshaft is securely pinned, and these are very snug fits. I'm going to put a little bit of tension on the belt just to get, and that is fully inserted. I can rotate it, that's correct. And I've also locked, if we can just spin this around carefully. What I'd like to point out is that the flywheel has been locked. It's an 8mm, I'm using a simple bolt, 8mm diameter bolt, fits snugly in the bell housing casting into the back of the flywheel. the flywheel is locked. That is not the locking pin through which the torque of the front pulley will be tightened. It is simply a timing pin, not a locking pin. There is a separate device for this engine that engages with the teeth and securely locks it so that we can tighten the front pulley bolt accurately. Out of interest, I mentioned the camshaft sensor. This is a sample, it's not the correct sensor for this engine. The crankshaft sensor on this engine works off the back of the flywheel. This section is called a phonic wheel, which creates a signal which is identified as the crankshaft position, and there's a similar set of teeth on the camshaft sensor. So basically the electronics know where the mechanical functionality of the engine is, and that's why the belt timing and the actual accurate pinning of the engine is so important. One final very, I think, important issue here. I did mention earlier this is a common rail diesel injection system which runs off of high pressure. With any dismantling procedure, and you'll notice that the low pressure fuel hoses have been removed, that we use the correct capping devices. Keep any debris. So anything you dismantle that wears potential of debris entering the engine, then treat it accordingly to protect it. We are going to wash this engine, of course. Of course, we don't want any water ingress internally. So that's also an issue for that reason. First consideration here, I've just removed the belt. Quite a large amount of oil contamination, which is an issue. You can also see there's oil debris there, which appears to be coming from the front camshaft seal. We took a look at the tensioner, in particular the runner, and listened to the bearing. There's a little movement in there. Otherwise, the bearing seems to have enjoyed a normal service life. Took also a look at the guide. Once again, listening to the bearings. No undue noise. It is going to be replaced. The serpentine belt, however, is a little hollow, and there is a little excessive movement in that. Generator, power steering, and those idlers appear okay, so we're going to replace that, the serpentine belt. Water pump, of course, we also mentioned the water pump as an issue, and of course we're going to clean the engine. So the next phase in this process now is to clean the engine.
Okay, Frank, so fitted the new water pump up, torqued all the bolts up, gasket in place as correct. What was the reason for change?
You may recall previously, whilst we were dismantling it, I drew your attention to this discoloration here at the bottom of the pump. It is coolant that's leaked, and it's what appears to have leaked over a period of time. It's actually part corroded the aluminium casing of the pump, and as predicted, it's leaked out of the drain hole at the bottom. So there's been a significant coolant loss across this engine. Now, of course, that in itself is a problem. Potential overheating of the engine, failure of the head gasket, failure of coolant is a bad issue. So just highlights that a job that's rushed, and if we hadn't have washed the engine perhaps, that may have been concealed by some oil and just passed off as oil contamination. So the actual process of washing an engine is not just aesthetic, but also technically very important. It's something we do an awful lot of. We take great care in it, and I think, to be honest, the presentation of finished product then complements the whole value of the job. On to the replacement now. So what we're going to do is get the belt kit ready. So it's a fairly straightforward kit, a roller, a tensioner, and a belt. The engine is still pinned. I've checked the flywheel. Camshaft is still pinned. We've kept the serpentine belt tensioner pinned back as well. We've pre-marked the high-pressure diesel fuel pump. I do need, however, to remove the idle tensioner. That's one part I didn't take off, but this is easily done. Let's discard that. There should be no issue with cross-contamination of new and old parts, but it's always advisory. Keep them separated. Slight design change in the bearing. It's nice. And the belt, I'm going to set it on the sprockets. So the only sprocket that can actually move is, of course, the pump, and we'll check that before we finally put the tension on, of course. Some of these belts are quite wide. This is the actual fact, and there is, I notice, a new retaining bolt, so we shall discard the old one. I made the point that some of these belts are quite wide. Don't be tempted to use any levers when installing them. It will cause damage, which is what I meant by looking for potential damage when dismantling. Yeah, that's actually in the right position. Ensuring the run of the belt, the teeth engagement's right. And the final. And once again, no tools, hands only. I do appreciate some of these are quite tough. At this point, I'm just going to do a preliminary check. That's okay. Pin in the flywheel is good. That is on. That mark is good. New bolt. Now, strictly speaking, the tensioning of this belt should be accomplished by the use of a tensioning gauge. I'm going to carry this out. It is permissible in this case to do it manually. I'm checking the alignment of the belt. And I guess I'm going to use the words experience. This is where a degree of experience comes in. Now, for the benefit of camera, it is important you rotate the engine at least twice it is processed to take up any slack and tension. Go back to the original pin position, ensure the pins go in, and then recheck your timing. But for the benefit of the camera, let's assume that we have done that. That is more or less it. I do make the point, however, you can and should use a belt tension gauge when fitting. Most belts that are manually adjusted, and this is one, do lend themselves to a belt tensioning device. However, within the instructions, it's permissible on this application to tension it in just the manner that I have. Generally speaking, about a 90-degree flex, no undue tension is about right. I'm quite happy with that. Just going to check and make sure that that is locked. I'm quite happy with that. Slight change in design also, that's a quarter drive. The old tensioner used a slightly larger size, so be prepared for some small updating components. That's the belt fitted. Next, the serpentine belt, and we can discard the old water pump, and the new serpentine belt is here. We need, first of all, to put the front pulley on, so I think we should do that. Once again, I made the point earlier that some belts, some engines are keyless. This is a Woodruff key. That locates the pulley in a fixed position, so there's no argument about that sprocket being in the wrong position. Be very cautious on those engines which are keyless. These sprockets are free to run, and effectively the sprockets can go anywhere. What you do is lock the engine securely by mechanical means, and then the position of that sprocket is then held by the compression of the pulley with what would then be a stretch bolt. So on the keyless engines, it's critical that they're pinned. And as I made the statement earlier, that the physical timing relationship can be correct, but the physical position of the crankshaft and camshaft can actually be incorrect with a keyless engine. It's a situation that we've come across so many times, all accompanied by the same statement: yes, I've checked the timing, there's nothing wrong with it. I think we'll try and run that up with the gun initially. This obviously will be subject to a specific torque, and for two considerations: one, for the benefit of filming, and secondly, for the fact that this engine is effectively unsupported on this build trolley. I don't want to be exerting a high torque in such a vulnerable position, so accept that this is going to be torqued correctly when the engine is in a more secure location. You'll notice that the choice of ratchet may appear excessive. The length of the ratchet is chosen so that a smooth progression force can be applied, which is a safer way of securing those type of bolts. Right, pulley on, all the other components are on, we're ready to put the serpentine belt on. I'm taking guidance from the electronic data. I've made an observation of the relevant fitting data, in particular the routing of the belt, and I must admit some of these are quite complex. I'm making sure it's securely in all the guides, and you'll notice that by locking off the tensioner it makes the fitting much more easy. And the next task is to remove the locking pin from the tensioner and to allow the tensioner to take up strain, check the belt run, and bar the shouting and the covers, that is one belt replacement.
So Frank, from the customer's point of view, that's peace of mind, that's a whole job done. Initially we just thought about replacing the timing belt. We've gone through all the other components, including the water pump, replaced them all at the same time. That makes a lot of sense for the end user.
It does. It's what we call value for money. I prefer to add value to a job rather than try and cut the cost. Generally speaking, cutting the cost is not a solution with a major consideration like this. Just to recap some of the most important issues: correct location of the engine, pin the engine whilst dismantling it, make sure the timing is right in the first place. You may find some issues. Do a risk assessment. Have a look at the basic condition. We spoke about some oil debris. We also noticed a problem with the water pump, which pretty much guaranteed we're going to change the pump anyway. Give the customer good advice. Try and retain control technically of the repair. The customer obviously takes control of the financial aspect of the contract, but try and persuade the customer of the value of doing the job right in the first place. Good value for money.
Great, nice and easy to do. All those parts available in a kit, and just check our website for the part numbers.
Sure. Quality parts.
Great.